So, did you see that we got 100% on our design, the study?
No.
See, we don't have to change anything?
I don't think so. Let me make
Oh, we
sure
nailed
I'm
it
not
then.
lying right now. Let's not talk about it though because Kimmy's here and she can't know exactly what we're doing.
Okay.
Okay.
No, we're just not going to talk about it.
All right.
Okay.
Do you guys have the prep open?
Yeah.
Yeah.
All right, the first one, what's the null hypothesis for the significance test comparing two population proportions? It's the null hypothesis equals P1 equals P2.
Yeah.
Right.
And then an alternative is 1 doesn't equal none, or greater than or less than.
Yes. So the second one is, what is the formula for a test statistic for testing two population proportions? So the formula is this one. I want to show you. It's so big, but it's easy, but it's so large.
I can say it fast for you. It's Z equals parentheses P hat 1 minus P hat 2 minus parentheses P1 minus P2 all over the square root of P hat times 1 minus P times 1 over N1 plus 1 over N2.
Hey, 1 minus P hat, Jack.
Yeah, that's what I have on there.
Okay.
Yeah. So that's it.
So P1 and P2, what do those represent?
P1 represent like the P1, the sample proportion for group 1, and P hat 2 is the sample proportion for group 2.
And then the P without the hat, that's the actual proportion?
Yeah, but it's always 0, right?
It's always 0?
Right? Or not?
I don't remember that, but I could have missed that.
Because if P1, according with the null hypothesis, is always the same, like P1 and P2, so it's 0.
But then we'd be multiplying by 0.
I don't think it's always, because that would give you a 0 under that radical. So I don't know.
I'm just looking through this real fast. I'm gonna look for the P's.
Okay.
So, she's right. Oh, not duh. Because P hat 1 minus P hat 2 isn't multiplied by P1, P2. It's minus.
Yeah.
Yeah, but look underneath the radical. It's the radical, and then P hat times 1 minus P.
I have it in the book right now, so let me share my screen. Okay. Oh my gosh, that's so crazy when that happens. Okay, so right here. In the null hypothesis, we assume that P1 equals P2. So subtracting P1 from, or P2 from P1 equals 0.
Yeah, but then look at their numbers. That doesn't make sense.
Well, what do you mean? Because they don't use P again. They only use P hat.
Yeah, the P hat underneath the radical.
Right, and
that's 0 multiplied by 1 minus P hat multiplied by 1 over N.
No, this is
P hat. P hat is always like the sample size, no, the sample proportion, but P1 minus P2 is their true proportion.
Right, and then this is the overall sample proportion.
Yes.
Not the actual proportion.
Yes.
So P hat is you get P hat by taking the sample or like the test number from 1 plus the test number from 2, dividing it by sample size of 1 plus sample size of 2. And that's the overall proportion. That makes sense. So, like if you're going to use two categories like males and females, then you add their probabilities together.
And that gives you, and then you divide it by?
Divided by the total sample size.
Uh-huh.
Yeah.
Cool. Okay, I see that. Oh, I just looked at his feedback. This is a tangent. I looked at his feedback, and you guys can see it right here. It says, this is a good start. Here are a few things to consider. I don't think your response variable is quantitative. I think it's categorical. The actual price of the item may be quantitative, but you have divided prices into two categories.
Okay, that makes sense.
Yep. So it's either one or two. It's not any of those other things. Yeah, it makes total sense. Second, if the person doesn't know what the study is about, what do you do if they bring back an item that's greater than $9.99?
It was hard to word that.
Yeah. So he just said, let me know if you have any questions. I'd be happy to chat. So I'll just talk to him about it.
Yeah.
Cool.
Because we want them to bring back items that are over $9.99.
Right. Exactly. We want items up in the 20s and 30s.
Or even over 100.
Even over 100.
Okay.
Cool. So question, or we're on
3.
Yeah. What is the confidence interval for comparing two proportions? Explain what each variable stands for in the formula. So the confidence interval is...
So you're going to need a z-score.
Right. So you're going to choose the z-score based off of what kind of confidence you want.
Mm-hmm.
And then, or I guess it's not your z-score, it's just your z. They should have chosen a different number or a different letter.
Your confidence interval number.
So you take sample size or the sample proportion from 1, and then you take the sample proportion from 2, subtract them.
Mm-hmm.
That's plus or minus whatever your confidence constant is.
The answer key says z value for confidence interval. I think that's a good definition.
Right, z value for yeah, that makes sense. And then multiplied by the square root of p hat 1 times 1 minus p hat 1 over sample size 1 plus p hat 2 times 1 minus p hat 2 over sample size 2. And this is going to be so hard to remember.
Well, we're going to do it right now.
Yeah, I mean, I hope on the test we get a sheet of paper that we can write these down.
We do.
Okay. So those. Oh, and then I guess I already said what the letters indicate.
Yeah, we did in the problem before.
Okay. So then, part 2. Use the following data summary to answer questions 4 through 6. There was a recent survey taken on whether consumers are label users who pay attention to label details when buying clothes. Are men and women equally likely to be label users? Determine if the proportion of men who use labels are different than the proportion of women who use labels with a level of significance as A equals 0.05. So 95% confidence means that Z equals 1.96.
Yeah.
Okay.
Well, we're supposed to check it, so we need to take, what is it, n times p, and see if that's greater than or equal to 10.
See.
Oh, right.
So 296 times 63 is definitely, oh, no.
296.
296 times 63 divided by 296.
Yeah.
96
Mm-hmm.
is equals 63.
Excellent.
So 10.
And then 251 times 27 by 251
Mm-hmm.
equals 27.
Ooh, it was close. Because then now you do 250, or you do 27 divided by 251, then you go 1 minus that times 251. That's 224. So that one works. Now 63 divided by 296, 1 minus that times 296 is 233, so that works.
Yeah.
Excellent.
State
the
null hypothesis. Alternative.
Men and women are equally likely.
So P1 equals P2.
P hat 1 P equals
No,
P hat.
P1.
P1.
Why is it not P hat?
because we are trying to find out the true population, right?
Right. You're right. Okay. P1 equals P2, and then the alternative is that it does not.
Uh-huh.
Mhm.
Okay.
So
Compute this test statistic.
I have the Excel thing. Do you want to?
Yeah. Yeah, let's do that. Danielle, which Excel thing are you using?
Let me check. Categorical data analysis. How do you say it?
Categorical data analysis.
Analysis. Yeah.
Analysis.
Okay.
Okay. So
let me check if I.
I like how it says oh my goodness.
Can you see?
Uh-huh.
Oh, no. Yeah.
Hey,
So.
did you make pie charts?
Yeah, it's because I don't understand in the beginning how, but I practice it. but I think the Z-score is 3.309. Oh,
The Z-score?
yeah, 3.309.
3.309. Let me check. Yep, 3.309. That's the answer.
Okay, I want to do this. I also want to do it by hand.
Yeah, so you take P hat or P1 minus P2. We
So
need the P
P1
hat
is
though.
P1, P hat 1 is 63 over 296. And that's 0.213 minus 27 divided by 251 minus 0.107 minus 0 all over the square root of the real P hat. What is? How do we find that again? We find P hat by taking x1 plus x2.
Yeah, it's the total. And
So
then divide that by
plus 27 divided by 296 plus 251.
yeah.
So that's 0.165.
0.165.
And then I multiply that by 1 minus 0.165. And then I multiply that by 1 over 296 plus 1 over 251. Okay, so now I have all those down. So it's 1 over 296 plus 1 over 251. And then it's that times 0.165 times 1 minus 0.165. 0.00101, and then it's that squared. No, the square root of that. And then it's 0.213 minus 0.107. Oh man, I've got to make sure I have that one right. 0.213 minus 7 over 251. 3.31.
3.309. Yeah. 3.31.
Oh, thank goodness. Okay, I can do it now. I didn't know. I didn't believe in myself. I didn't know I could do it.
A lot of numbers.
Yeah, that was crazy.
And now, someone figured it out, and that's supposed to mean something. And we're just supposed to trust them.
Well, yeah, that says, what does that mean? That means that the probability that that P1 equals P2 lies outside of 3.3 standard deviations.
Yeah, and that's not very likely.
No. So that makes a p-value of 0.001. So we are rejecting the null hypothesis.
Mm-hmm.
Get out of here, null. Okay.
And then shade your p-value in the normal distribution. So it's way.
Yeah, you can't even see it.
Yeah, z-score 3.309.
Yeah.
What decision do you make of? Oh, it's what?
No. I get 9.3630, but this is like no por 10 a menos 4.
Right. It's like the opposite. Right?
Right.
Cool. Okay, well, I guess we can take the quiz now.
Mm-hmm.
Or was there one more question?
There's a couple more questions.
Oh.
So F is, what decision do you make about the null hypothesis? Well, you reject it.
Yes.
Mm-hmm.
We have sufficient evidence.
State your conclusion in layman's terms. That we have enough evidence to reject the null hypothesis.
Right, but
that men and women are different when it comes to looking at labels on clothes, the details of labels.
Right.
Mm-hmm.
Men do not pay attention to the details.
Okay. Construct a 95%
or women.
interval.
Construct a 95% confidence interval for the difference of two proportions in number 4.
So it's 0.045 and 0.166.
Mm-hmm. And then interpret the confidence interval you constructed.
We are 95%, not 95,
Yes.
confident that
the 95% of the true proportions lie within that.
95% of 95% confident that 95%.
Right. We're 95% confident that 95% of the true proportions lie within those two numbers.
All right, let's take this quiz. One and two are true.
Right.
Oh, sweet.
So we know we at least got 4 points.
Yeah.
For the next 9 questions, we will review the PTC tasting study with different data. Out of 70 females in the sample, 52 can taste PTC. Out of 59 males in the sample, 42 can taste PTC. So 52 over 70. .743.
I haven't put it in yet. And then 42 out of 59 was p hat 2. 52 divided by 70.
0.743.
Yep.
And then p hat 2 is 0.424.
What?
It's 0.712, no?
Yes, 0.712.
0.
Did you do 17 or did you do 42?
What?
Did you do 17 or 42?
I did 42.
42 divided by 59?
Yeah.
Oh, yeah.
No, I did. What the heck? I did 25. How did that happen?
I don't know. Okay. So let P1 is females, P2 is
Guys,
males.
it's 0.712.
Okay.
Yeah.
So the first one is 0.743.
Yeah.
The second one is 0.712.
Yeah, 4712.
Mm-hmm.
Okay, and then 5. Which set of hypotheses is appropriate for addressing the question? P1 equals
First
P2.
one?
Yeah. Create a 95% confidence interval for P1 minus P2. Put your answer so that what is the point estimate for 95% confidence interval?
So we can.
We can use the app.
Point estimate, that's not our test statistic, is it?
One is mm,
Come on, load computer.
yes, P1.
And what is the point estimate?
I'm trying to open up the homework again.
I think the point estimate needs to be like the square root, like about P1 times 1 minus P1 divided by the like the N1 plus, I think this is
Does that give us our z-score?
no, it's without the z-score, only the square root thing.
Oh, so it's that, and then you times it by the z-score? Or by the z
So
for 95%?
A single value given as an estimate of a parameter of a population.
What is the point estimate? Oh, I see what she's saying. It's P1 plus P2 over the over X1, I mean N1 plus N2.
Yeah.
I think so, yeah.
So, okay. So we take 52 plus 42, is that right?
But you got to use a 95% confidence interval in that.
Not yet.
To get
That's
6?
just what we start with.
Oh, okay.
I think so. 52 plus 42, and then it's divided by 70 plus 59. You guys see what I'm talking about?
But we still need to use the 95% confidence interval.
I think we use it to find.
Why would they ask us that?
Because
I think we.
Because that's what you use. That's what makes this whole thing significant. Like that's what makes it for this problem.
Mm-hmm.
Because I think so. If we go 0.728, because that what I just did equals 0.729 times 1.96 gives us 1.428.
Okay. Yeah, so you take P1 minus P2 and then you divide that by N1 minus N2.
I think
and that multiplied by the z-score, that is
by 1.96.
So I'm realizing what I did wrong. So you're saying that we need to do P1 minus P2?
It's like this formula. I'm gonna show you. Okay. Oh, it's not. Okay. I don't know if you could hear it. Like is this?
Yeah, so it's underneath the radical. P hat 1 times 1 minus P hat 1 over N1.
Okay.
And then you multiply You square
By
root
the
that, and then
z-score.
you multiply
I
that
see.
by.
Okay, so 0.743 times 1 minus 0.743 all over 70.
Yeah, 70
And then is it plus or minus?
plus.
Plus
Plus.
p hat 2, which is 0.712 times 1 minus 0.712 all over 59.
Yeah.
And then it's the square root of those two things together.
Yes. And
Yeah.
then you multiply that by the z-score
Right.
or the z.
But is that included in the test statistic?
No, it's with because in the test statistics you need to.
Yeah. So then you take the average of P1 minus P2 and you add and subtract that number from it, and that gives you your endpoint, your lower bound and your upper bound.
Right.
Mhm.
1 minus 0.72 all over 59. And then that's the square root of that. So 0.0787 times 1.96. So then it's plus and minus 1 or 0.1544.
So the point estimate is 0.1544.
You know, that's the margin of error. When you multiply it by 1.96, that gives you margin of error.
What is there?
Because I think I just found the margin of error, which is the next question.
Yeah. So
Point.
you add and subtract that number.
No, the margin of error. Oh, right. And that number is the margin of error. Adding and subtracting it gives you confidence interval.
Yeah.
Yeah.
So the point estimate was the step before we multiplied by 1.96.
Yeah.
Okay, so then that one was 0.079.
0.079.
That's what I got. So take 0.079 and multiply it by 1.96, and what do you get?
Uh, 0.155.
Right. So I have a lot more numbers than that in the 0.079, and so like the true one is 1.54.
Mine says 1.5484. But
Well, yeah, we should round it to 5. You're right. I'm not sure why.
But that's not our that is our margin of error.
Right, that's margin of error.
It's 0.155.
0.155.
And then input the lower bound.
Yeah, I have the lower bound.
Okay.
I think is minus 0.123.
Excellent. And the upper bound?
Is 0.185.
Awesome. With alpha equaling 0.05, what decision do you make?
Hold on. I ran the numbers again. The margin of error is 0.154 because if you do the point estimate at 0.078761646 times 1.96, it ends up being 0.15437.
Okay.
I missed question 8. What was 8?
8 was negative 0.123.
And then 9 was
0.185.
0.185.
And Daniel, you got those off the Excel sheet?
Yeah.
Sweet. What was the p-value?
The p-value is 0.653.
So we fail to reject the null hypothesis because the p-value is greater than alpha.
Right. It's greater than 0.05.
Yeah.
Fail to reject the null hypothesis. Oh, the alternative almost got me.
It's not HA, it's HO.
Yeah, it's not.
Now,
Okay.
which statement? There's insufficient evidence.
To suggest that the true proportion of females who can taste PTC is less than the proportion of males.
That's different. It's not
different. There's insufficient evidence to suggest that the true proportion of females who can taste PTC is different from the true.
Because
we
did a not equal to.
Right.
It's the last one?
It's the last one.
No, guys, we still have 12 through 20.
Oh, Andrew, the last option.
We got to go fast, though, because I got to leave in a couple minutes.
Okay. For the next 9 questions, we will review the mortality rates and day of admission heart attacks. Out of 118,519 who had heart attack during the weekday, that many died. Out of 42,000 that had heart attack on the weekend, 6,155 had died. Okay. P1 is the proportion of patients who had heart attacks and were admitted on the weekday who died. P2 is those who were admitted on the weekend.
Who died?
95%. Yeah.
So we're comparing those who died to the total number, not the survived number. The survived.
Yeah, those who died to who came in.
Yeah, the survived is an irrelevant number for us.
Right. So 16,713 over
118519.
118,519. That is our P hat 1.
Yes.
And then 6155 over 42447 equals P hat 2. Okay. The condition, we have to see if they work. So 16,713 divided by 118,519 times 118,519. That works. They both work, or not. P hat 1 works. I didn't do P hat 2.
I'm gonna guess that it works. Because
Yeah.
if it didn't work, then we couldn't do this problem.
And it works. I just did it.
I
did it. It's true.
And we're doing a less than. The proportion of patients who have heart attacks are admitted to the hospital on a weekday who die less than the proportion of patients who have a heart attack who are admitted to the hospital on a weekend who die. So P hat 1 is less than P1 is less than P2.
For a hypothesis alternative.
So it's the fourth one.
Yeah.
Use the data in the table to find P1.
Okay.
So it's
16,713 divided by 118,519 is 0.141.
It's not 0.141?
Yeah, it is 0.141. I think when I say point, I don't really say it clearly.
Oh, I'm sorry.
Yeah, that's okay. It's my fault. Okay.
6155 divided by 42447.
It's 0.145.
Yep. 0.145.
Z-score.
I could point. You can use. So what is X1?
Well, do we need it for the Z-score?
No. To put that in Excel, in the Excel thing.
Oh, sorry. X1 is 16713.
6713. And N1 is
N1 is 118
uh-huh,
519.
519.
Yeah, 519.
And X2
X2 is 6155.
155. Uh-huh.
And then N2 is 42447.
Okay. So the p-value, right? Or z-score?
Z-score.
We're looking for z-score.
It's minus 2.020.
Sorry, I trust you, but I'm doing this for practice. I'm just doing it real fast.
Uh-huh.
And I'm almost done with it.
2.0.
And the z-score can be positive or negative. It doesn't have to be negative.
Right. Okay. Okay, so then that's 0.142, 1 minus. Okay, I'm almost done. So that. Okay, sorry, I got it. What did you say your number was?
For z-score,
Yeah.
2.020.
So I did it with all the numbers, like completely, and
Uh-huh.
I got 2.0255.
Uh-huh. What did you get?
I got 2.0255.
0.0255.
I'm gonna put it in as 2.026, and I'm gonna see if I can change it if I get it wrong.
Was it negative or positive that you got?
I got negative.
Because that's important for 17.
Okay, so I got negative.
You shade to the left
Okay.
Yeah.
because it's negative.
Yeah. So what's the p-value for that? I'll put it in the applet.
Daniela, did you have it in the applet?
Yeah, it's 0.022.
Do you want to put in negative 2.026 and find that one?
Yeah.
Because we need the negative one.
Negative what?
Negative 2.026.
And it's only the left, right?
Yeah.
So it's 0.0214.
So 0.021. Is that the same as the other one?
In Excel, it's 0.022.
Yeah. So I'll put in the one that I did for my numbers. You guys can put in the Excel one if you want, and we'll see which one it takes.
Yeah.
19, Alpha was 95%, so it's 0.05. So we can reject the null
We
hypothesis.
reject that. Yeah, we reject that thing.
Just send that straight out of here.
Yeah.
There is sufficient evidence to reject it.
To conclude that the proportion of patients who have a heart attack and are admitted to the hospital on a weekday who die is less than, so the second to last one.
Uh-huh.
The last, yeah. So before you submit, can you tell me question 8?
Yeah.
I think it's 8.
So question 8, I have negative 0.123.
No. It's question 6. I'm sorry.
Uh-huh. I have 0.079.
0.079. Okay. Thank you.
A moment of truth here.
Someone submit that, mama.
I'll submit it. Okay. Farts. I got 2 wrong.
Which ones?
I got so that z-score, when I computed it with my numbers, it was wrong. So it's got to be the one you said. It was negative 2.020.
Mm-hmm.
Okay, and then the other one we got wrong was the point estimate. We're not knowing what that is.
Yeah, question 6 is wrong. Do you have?
Yeah, question 6 is wrong. So let me a single value given as an estimate of a parameter of a population. It's not overall sample proportion, is it?
Point estimate should just be one number.
Right, and that would be the p hat without any numbers.
Okay.
Would that be p hat 1 plus p hat 2 over n1 plus n2?
Let me see.
Because p hat 1 is the number, or is your x over your n.
Right.
So then is this one, because we're using both of the numbers to compare, is it the difference? Is it like the average of the two together?
I don't know. That's the thing. Like I just have no idea.
I'm gonna try that. So it's P1 is, or it's 52 plus 42 over 70 plus 59.
Okay, I found it. It was from the last one, or like the last lesson.
Yeah.
It says p hat is called the point estimate. So it's not the one with the p hat 1 or p hat 2. It's this one. Let me turn on
the overall sample proportion.
Yeah, it's the one that you go x1 plus x2 over n1 plus n2.
Yeah, that's what I just said.
Okay, I was reading, so I couldn't hear you, or I wasn't listening.
Yeah, so it's 42 plus 52.
Right.
Over, it's 94, divided by 70 plus, what is it, 59?
Yeah.
60.343.
Okay. Let me get it back. Let me get back to the quiz again.
I'm going to submit it.
Yeah. Wait, did you fix the other one?
Yeah.
Oh, no, you had the right one. I had a different one.
0.020. Oh, I missed. That's one of them's wrong.
Darn it.
Which one did I get wrong? Nope, 60.343 is wrong.
For question 6?
Yeah.
Heck. Let me see if I can run it again. So,
Well, I'm gonna have to go. I can't stay anymore.
all right.
But
Cool.
if you guys get it right, let me know how you got it right, and I'll
Okay.
do the quiz again.
52 plus 42 divided
guys.
by. See ya.
Bye.
70 plus 59. Oh, that's why, because he got his numbers wrong.
Yeah, it's 42.
So for 6, you have to say 52 plus 42
Uh-huh.
divided by 70 plus 59.
Yeah, I get 42.403. No, it's 42 plus 52
Right.
divided by 70 plus 59.
Yeah, and I get 0.728.
0.728.
Oh, I have 0.79. I think it should be, 0.729.
0.729?
Yeah, I think that's what it should be. Have you submitted yet?
No.
Yeah, you should submit it and see.
No, I submitted.
Okay. And you got it right?
No.
Oh.
No, because I have the other.
The old one.
Mm-hmm.
Okay, well then let's go back. So the answer to 3 was 0.743.
Mm-hmm.
0.743.
4 is 0.712.
0.712 is 4.
Uh-huh. 5 is the first one.
5 is the first one. 6, I think that 6 is 0.729.
Okay.
And then the margin of error, did we get that right?
0.155.
0.155.
Mm-hmm. 8 is minus 0.123.
Okay.
9 is 0.185.
Okay.
10 is fail to reject.
11 is
Insufficient, the last one.
the last one. Different. That's right. Okay.
12 is true.
True. The last one is, or the 13 is the last one, right?
Right. And then 14 is 0.141.
Okay.
15 is 0.145.
Okay.
16 is minus 2.020.
Okay.
17 is to the left.
Right.
18 is 0.022.
And then
19 reject.
Right.
And 20 is the second last one.
Okay. I'll submit it and see.
Mm-hmm.
I still missed one. Okay, well, let's see which one it was. It was still question 6. Man, I'm going to email him about it because I'm not sure how to figure that out.
Okay.
Yeah. Okay, well, I think we're good.
Thank you.
Yep, thank you. Have a good one.
Yeah, thank you. Bye.
Bye.